This is a spring scale. The outside is made up of two casing components, held together by screws. The basket on the bottom provides a place for masses to be placed. As an object, such as a fruit, is placed in the basket, the red pointer rotates, indicating the mass's apparent weight. However, if we take the whole scale apart, we can see that it isn't so simple. As you can see, there are several complex components and elements to this scale. Let's take a look at them all. Back at the front view, we can see that there may be issues with the scale not aligning at zero, even when no mass is present in the basket. To counteract this issue, the scale has a built-in calibration screw. As the screw moves, the red pointer is adjusted. To understand how this works, we must first understand how adding weight to the basket causes the pointer to move. The basket is connected to a hanger, which extends inside of the mechanism. The hanger is attached to the spring connectors through a rotating mechanism, which relies on gravity. This allows for an easy real-life assembly process. The springs are then attached to these components on both sides, providing resistance to the force on the system due to the object's mass. Attached to the previously mentioned hanger is a rack, connected to the hanger through the rack attachment by screws. The rack translates the spring's linear motion into the pointer's horizontal motion using a spur gear. This relationship is defined by Hooke's law, which is what allows the mechanism to work, as the relationship between how far the springs move and how far the pointer rotates is proportional. The spur gear is encased to help prevent any potential interference. This casing is connected to the outer shell with screws to ensure that the gears stay centered. This is necessary as the gear then extends outside of the internal mechanism, where it can be seen protruding the scale's face. This is where the pointer is attached, with its motion limited by the gear's shape in this hexagon-shaped cover. This is all protected by the plastic covering, which is attached to the scale's face. Now, understanding how the spring scale works, we will look at how the calibration screw actually affects the position of the pointer. As the screw rotates further into the mechanism, it pushes on the two cams. This causes the pointer to move ever so slightly as the screw is rotated in or out, allowing it to zero properly. The cams are held together by pins. These are protruding through the top component. This piece is attached to the outer casing via screws. It also hangs on the top hook. The calibration screw is put in place by the threaded hole on the top. Force applied by the screw then causes the cams to move up or down, depending on the direction that the screw is moving. The contact simulated by the edges of the cams causes the holes to rotate a proportional amount, moving the entire mechanism up or down as well. And that's how a mechanical spring scale works.